Hello everyone, my name is Nur Akila, and for today I will be talking about the results and also the conclusion to this experiment. So first up, the results for open eyes. So as shown on the screen, this is the raw signal obtained from the EEG for open eyes. So as you can see, it's not defined, the shape of the signal is not defined, and you can't tell which line represents what reference, which is why we denoised it. And so this is the results after denoising it. So as you can see, it's more defined and you can tell which line represents what reference. So for example, the blue one represents the C3 reference, while the orange one represents the C4 reference. So after getting this denoised signal, we can observe its shape and also compare it to the the type of brainwaves shape that we have. So for example, for this one, we all came to the conclusion that so the next results that we will be looking at is for closed eyes. So as you can see on the screen for the raw data here, it's very erratic. You can't even estimate the magnitude of the signal. You can't even imagine the overall shape of the signal, which is why denoising is very important. So after denoising this signal, as you can see, we've obtained a shape. We can certainly see a shape here, but if you look closely, there's only the blue blue and purple line existed here. So the blue and purple line indicates for C3 reference and also O2 reference, but for C4 and O1, it only exists here in the beginning. Okay, so after observing this brainwave, we've come to the conclusion that for closed eyes, the alpha wave is present. The next results is for blinking. So this is the signal that we've obtained. So as you can see, there's definitely a pattern here. There will be sudden drop in magnitude of the signal and it will increase all over again, and it happens periodically. So after denoising this signal, this is the shape that we've obtained. So after observing and comparing its shape with the brainwaves that exist, we came up with the conclusion that the type of brainwaves present during blinking is the beta wave. Last but not least, the results for tracking a moving object. So as you can see, this is the raw signal for tracking a moving object. So there's definitely a pattern here. There's a sudden drop and sudden increase of the magnitude of the signal. But we don't know for sure. We can't imagine the overall pattern for this signal because it's so unclear and unobservable, which is why we need to denoise this signal. So after denoising it, this is the shape that we've obtained. So as you can see, the blue line, also known as the C3 reference, is the only clear line that we have for particular signal. All the other three reference point, it's not very clear, and it will suddenly disappear. It is here and then it's not the next second. Okay, so by just observing the and comparing the wave for C3 reference, we came up to the conclusion that for tracking a moving object, the beta wave is present. For this experiment, we've chosen to calculate the RMS value of each reference point for each activity. So for example, for open eyes, so this is the RMS value of C3, this is the RMS value for C4, O1 and O2, and after obtaining all four RMS values, we calculate the average RMS value for open eyes. So the average RMS value for open eyes is 51.39 millivolt. For closed eyes, it's 23.35 millivolt. For blinking, it's 66.43 millivolt. And for tracking a moving object, it's 72.89 millivolt. So as you can see, The largest RMS value goes to tracking a moving object, followed by blinking, open eyes, and finally closed eyes with the smallest value of 23.35.